Okay, chapter number 10 is about regression and correlation. That is important. Why that's important? You will know why. Okay, the previous chapter looked at comparing populations to see if there is a difference between the two or among the three. Actually, later I will show you how to run the one-way ANOVA. One-way ANOVA is easier, but two-way ANOVA is very complicated. Even it's troublesome for me. That involve the two random variables that they are similar measures. This chapter will look at two random variables that are not similar measures and see if there is a relationship between those two variables. Okay, let me try to slow down. Two variables, for example, your height and your body weight. They are two measures. Does it have any correlation? We don't know. Okay, for example, my cholesterol level in my blood and the money in my pocket. I'm a rich man. Actually, I'm not. I wish I would be a rich man. Okay, the money or deposit in your bank and your cholesterol level, they are two different value measures. Do they have any relationship? We don't know. Okay, again, when run a regression, we try to find two different things, or we call it two different variables. Is there any correlations over there? And now we need some mathematical tools. Regression is one of the powerful tools. And sure, the first time I learned the basic concept is when I was a high school student. But I really understood how to use it. That is very late after I became a master student. We need to run the regression and correlation and find it. But the tools, listen to me, the tools, the operation is pretty easy. But the concept is in the middle level of the difficulty. But the calculation is very troublesome. I can say hard, I say troublesome. And now this time, I will not ask you to calculate step by step. We will use the tools and get the regression and correlation. But here, regression, there are many ways. For example, the linear regression is the most useful, most common. And if the number get a logarithm, the value, we can do the regression. For example, the microorganism, the growth curve, we get a time and the microorganism, the number. After the number get the log value, and that is had a linear correlation to the growth time in certain field. But we may not do that. Okay, let's move. And note, there are many types of relationship besides linear. There can be found for the data. This book only explores linear, but realize that there are other relationships that can be used to describe data. Okay, regression. Okay, when comparing two different variables, two questions to mind: is there a relationship between two variables, and how strong is the relationship? These questions can be answered using regression and correlation. Regression answers whether there is a relationship. Again, this book will explore linear model, not a logarithm model, only linear model. Okay, and correlation answers how strong is the linear relationship. To introduce both these concepts, it is easier to look at a set of data. Example, if there is a relationship is there a relation between alcohol content and the number of calories in a 12-ounce beer? The alcohol content is one measure. The number of calories is the other measure in this test. To determine if there is a random sample was taken of beer's alcohol content and calories, and the information is from here. The data in example is here. See, 4.7 calorie, 163. 6.7 to 215 calories, like this one, like this one. It seems something. We observe those two sets of data, and we can say maybe the higher the alcohol content, the higher the calories. Maybe, but according to observation, it's not easy to get the details. If we use the computer software, it's easier. Let's check here. Later, we will do the calories and alcohol content. We can make this one, the x-axis as the alcohol content from 2%, 4%, 6%, and 8%. About the calories, 0, 5, 100, 150, 200, 250 calories. And see, it seems there is a line, median line over there. And the scatter plot, okay, scatter plot look at fairly linear. However, notice that there is one beer in this test is actually considered a non-alcoholic beer. Why? Because that beer, the alcohol content lower than 1%. Okay. You cannot just remove data point, because in this case it makes more sense too. Since all the other beers have a very large alcohol content, like this one, and this one, this concept is remove the first one, then we can see this one we call residuals. Residuals, what does it mean? If we got a line, we try to make a line, the formula is y equals ax plus b, because it's a linear formula. And we got the red line this. And each line, the distance in y-axis or vertical distance from the line, between the line and the spot and the point is called the residuals. If we have a way to make the sum of residuals as small as possible, to make it the minimum value, then we can say this line is the regression line or correlation line. Okay. And here, give a collection of paired sample data. The regression equation is y hat equals a plus bx. But in Taiwan, we call it 1 equals ax plus b. Either one is okay. When the slope is b, and y-intercept is like this one. Okay, and the residual is the difference between actual value and the estimated value. Residual equals y minus y hat. Okay, I know someone feel headache about this one. If there is a red line going across all spots over there, then this line try to make the residuals. What does it mean? Residuals, the distance in vertical direction from the spot to the line is called the residuals. And if I can find a line that is smaller than this one, so try to find that, make every sum of the residuals very, very small. And we can call this line is the trend line. Okay, let's come back. SS means the stands for the sum of squares. So you can sum up all squares with the subscription xy, and they are not really summing squares, but you can think it is a way a wider sense like this one, Okay, one more question. Why we try to make it square? We try make it square. Not me. The scientists made this rule, not me. I'm not the scientist in the early age. Very easy. You can observe that some spot on the above of the red line, some spot below the red line, and we can know that if we use one way to subtract the other way, above the red line, the value can be positive. Below the red line, the value can be negative. Similar concept as we calculating the standard deviation. If we make the value a square value, then all values can be positive. That's why they make a square value like this one. Okay. The easiest way to find the regression equation is to use a technology. Sure, I will tell you how to do that. This independent value, we call it explanatory variable or predictor variable, is the x value in the equation. The independent value is the one of the use you predict the other variable is. The dependent variable depending on what independent value you pick, like this one. And here the population equation like this one. Y equals beta 0 plus beta 1x, similar like that one. Here y hat is used to predict y, And sure, you look very okay. I will explain this part, then we can run the math. We will use Google Office. Standard random variables, y alcohol content in the beer. So x is the variable about alcohol content in the beer. Y, the calories in 12-ounce beer in a can. A random sample was taken as stated in the problem. For example, 10.1.1 scatter plot. Later, I will show you how to do this. Looks fairly linear, like this one. And you can see that y hat equals 25.0 plus 26.3x. Then we find this one. After we have this formula, we can calculate a reasonable value. You can calculate from y to x, from x to y. Later I will explain this. Okay. From this you can see the y-intercept is 25.03. The slope is 26.32. The regression equation is like this one. And remember, this is an estimate for true regression. A different random variable will reduce a different estimate. So will produce a different estimate, like this one. Okay, and now after we have that, we plan. If you drink a beer that is 2% alcohol content, and that probably close to 78 calories. Again, after the prediction, why we want to know the regression, the formula? Because we can do the prediction. After that, we try to predict 2% of the alcohol. How many calories over there? You can check here. According to the formula here, alcohol content is over here, and 2 is over here. And sure, the 0 calorie was removed, and you can use it, but the 2 is below the 4. Sometimes it's not reasonable. You can say that the formula is from about 4.2 or 4.3 to 8.1% of alcohol content. they will not include 2%, but according to the formula, we can calculate about 79 calories. Okay, and now please have a Google Office here. Please have a Google Office. Let me tell you how to do this. Okay. Okay, please have a why no response? Why? What's wrong with this? Okay, got it. Please have a new Google Sheet, a blank spreadsheet, and rename the file name as 2026 June 01. And that is chapter 10.1. Chapter 10.1. The website is here. The website is here. Then copy the original data here. 99.3. Copy and move it to our test. Okay, and now we are there is a trick here. There's a trick here. If we plan to see the plot, the data on the x-axis, that should be in the first column. Actual content in the first column is okay. Let's check. Collect information here. Select. Then insert plot chart. Okay, chart. And scatter chart, that is correct. And now we know the first one can be echo-free echo, so we do not select the information. For example, the first one is here. Maybe we can delete it. Then select the range, insert chart. The key step is select scatter chart. You take photos like I'm a movie star here. Yeah, actually, I'm live streaming now. You can check my video. Okay, sure. You are welcome to take pictures of it. Again, select the data range and insert chart and select scatter chart. Please do this. Then please confirm that on the x-axis that is actual content. On the y-axis is calories. It's okay. If we want to switch x to y, y to x, you just switch to columns, data of columns. Okay, then next, here is one of the key steps. Move to customize. So I select the British English. So here is MISE. It's okay. I prefer to use British English because the page will become A4 setting, not the later setting. Okay. Chart style, axis, series. Please click trend line. Show R square. Again, move to customize. Move to customize and click trend line. So where is the formula? I need a formula. Okay, let me check where is the formula. Another title. Deacons, no. Sorry, line tricks, no. Okay, who can find the formula and check the formula? Okay, let me check. No, not this one. Switch row or columns, no. Label, no. Data label. It's okay. Linear, yes, and constant show R square. Hey, sorry, I cannot find it. Who can find the show the formula? Then we will see the y equals ax plus b. Yeah, I practiced that yesterday. It was okay, and here, please do not check the error bars. Please do not check the error bars. Why? Who can tell me why? Extra point, bonus point. Actually, or to challenge it? Why? Why I don't encourage you to check error bars? But you may say, hey, hi, Dr. Zhang, you show the Jerry's poster and there are many error bars over there. How can you do not encourage us use the error bars? Who want to challenge this question? I don't encourage you. And here, linear, exponential, polynomial, logarithm, and power series, and move average. And you can use that for different purposes. Okay, and now, is it okay so far? Okay. Oh, okay, I got it. Sorry, I just checked it. Here, how to get the Google Translate here. Select data, we did it. Chart, did it. Scatter, we did it. Translate, we did it. Then show equation, use under label, select use equation. Okay, thank you. I showed the series translate label. Oh, okay, got it. Use equation. I forgot this step. Okay, move to customize and check translate. I don't encourage you use the arrow bar. Okay, who want to challenge this? Otherwise, I will answer it. No, sorry, I shouldn't say that, but it's not the appropriate answer. Okay, I will answer it. Where to get the error bar? What does it mean, error bar? Error bars are the average plus 1 standard deviation above minus 1 standard deviation in the bottom. Do you agree with me? Do you agree with me? Okay. And next, how can you use just one data without 3, then you can get the standard deviation? Is unbelievable mistake. Again, in the originally we have only, see, is y-axis 163 to 15. Only one number is impossible to generate the error bars. At least 3 numbers. We get a mean, we get a standard deviation. We cannot generate just from one number, then we can get the standard deviation. In other words, it's fake. It's fake. Get it? Okay, sorry, I may postpone a little bit of time. Let me finish this part. Okay, then select the range, delete the first, the lowest number, and click. So where's the number? Okay, and select customize, and go to the series and check the trend line. I don't encourage you to use the arrow bars because it makes no sense. It makes no sense. I think it's a mistake from the software. Then next, move to the label and select use equation. Okay, 30 seconds. I will stay here. Let me have my coffee. Then click OK. So the answer is 2,632 times x plus 25. Let's check the question. Let's check our textbook. Our textbook at the calculation, the answer is 25.03, 26.2. Why? My answer is 2,600. Okay, go ahead. If you leave, if you are busy or if you have busy, you can leave right now. I need to finish this part. Okay. Who can tell me? 25 is okay, but 26.30 32. But my answer is 2,600. What's the difference? Who can tell me? No extra bonus because it's easy. Oh, okay. Bonus. 1 mark in the final grade. Actually, I already got 2, right? I think it's kind of positive encouragement. Okay, who can tell me? According to the textbook, 26.32, but my calculation is 2,632. Why? Ten seconds, then I will answer it if no one wants to. 10, 9, 8, 7, 6, 5. Last 3 seconds. The graph, sure, you can see for 100 times. Actually, if you are busy, you can leave the classroom now. The graph. 2,632, but according to the textbook, it's 26.32. Why? How can I get the same number as the textbook? 5, 4, 3, 2, 1. Okay, can I answer it? Decimal part? Decimal. Oh, okay. Can you say that again?
Just right. You have 2 decimal points, right? So out 1% calories. So if that is the case, so 2632 can also same number, but you just only put the decimal point.
Yeah, you got it. Great. Hey, write down your serial number and line group. Okay, get it? Because in our calculation, the formula, the software records the value as 4.7, but in fact it is 0.047. Again, 0.407. Then it recognizes different. Sure, either way is okay. If you use the 2,632, we can transfer, we can convert the decimals. It's okay. Get it? Okay, then after that we know one thing that, sorry. So we have the formula like this one. We have R square value. R square value we will explain next time. And next week I will tell you, if I have a 2% ethanol over there, can we calculate how much calories it may have? Okay, sorry, postpone the time. Okay, see you next week. Next week we will move to class B510. Not here. Until final exam. Okay, have a nice Monday, everyone.